Hello friends, this is Dalpat Sonagra, Assistant Professor in Computer Science Department, Government Women Engineering College. In this lecture, we discuss simplification of context-free grammar by elimination of null production. This is part 1. Later on, we discuss part 2, in which we discuss theorem that eliminate a null production in a given context-free grammar. So very first we discuss what is actually a null production. In a context-free grammar, the form of production alpha tends to beta, where this beta is only null, then this form of production is known as null production, like this, where A tends to null, where A belongs to the variable V and the right hand side of this is null. Okay, and this variable A is also known as nullable variable. Means in a context free grammar, if any variable that can derive the null string, that is known as nullable variable. Okay, so if we consider a grammar G and the production of grammar G is like this, then of course the B tends to null, means B is a nullable variable because it derives null string. Okay, and A is also nullable variable because it is also derived null string. Again, as also known as nullable variable because S derives A tends to B, and further in a course of derivation B, A and B also replaced by null. Therefore, this S is also known as nullable variable like this. Okay, and of course this is what the null dot null is null. This is a string operation, and you can say this is also a B. Okay, therefore we have seen that S derives null string after the multiple transaction. Therefore this variable S is also known as nullable variable. Hope you understand this. Okay, here we discuss more about null production and causes of null production in a context-free grammar. So note that in any context-free grammar, null production are only used to erasing a particular variable in any course of derivation. Like if we see in this derivation according to the grammar G, then you can see this variable A is erased by using null production. Okay, so in any context free grammar, if the null productions are available, then those null production are only used to erase the variable in the course of derivation. One more thing, if language consists null string, then there is a useful null production that is associated with the starting variable. That means if the S is S is starting variable, then S tends to null gives us the language of G having the null string. So this may be useful, but it can also be handled by using one additional production which we see in our next slide. Okay, hope you understand this. Therefore whenever a null production are available in a context free grammar, then by using some procedure we eliminate those null production and make the grammar simplified or reduced. Okay, here we consider a grammar G that describe like this, and the productions are this, and where two null production, S tends to null and A tends to null. Okay, so and language which is described by G like this, which is any occurrence of A, and the occurrence of A is greater than equals to 0, or in other words we can say occurrence of A is n, or an occurrence of A. You can read it by any way. Okay, so whenever a comes greater than equals to 0, and which is derived by this grammar, and you can see in this derivation, if we are if suppose we want to derive 3a and the value of n is 3, then that can be derived like this sequence. Okay, and suppose if we want to derive 2a, then at this stage we apply s tends to null and we erase this also, so we get only 2a's. So we understand we have this grammar and there are two null production, s tends to null and a tends to null, and the language of this grammar is n occurrence of a, where n is greater than equals to 0. Now look, if we want to remove a null production, a tends to null, because we know whenever a is encountered into the course of derivation, that is erased by using null production, a tends to null. Okay, so if we want to eliminate, then easily we can eliminate this production from the set of production p in a given grammar g. But due to the elimination of this null production, we have to add or change into the set of production. Okay, like this, because s tends to small a capital A is a production in a grammar G, so it should be uh, change like s tends to A, because we eliminate this, because A tends to null, we know we have a null production, so we change into the production itself, that is we eliminate this A, and we get new production, but we include both these production into our set. Okay, or because there is no use of this A, because this never come into any sentential form, therefore there is no need to include this. Okay, I hope you understand. Okay, because A never comes into the sentential form, so we use only this. So the final simplified production are s tends to small a capital S, and s tends to small a only, and s tends to null. Okay, and s is our starting variable, and a is a terminal, and a simplified set of vertices variables in a simplified grammar G1 is s only. Here we eliminate a also. It is not always because in like this a will not include here, but sometimes we have to include in this format. Okay, both this can be included, but it is totally depends on the grammar to grammar. In this grammar this may not require, therefore we eliminate this production and also eliminate the variable a into the set of vertex, but it is not for all the grammar. We will discuss it later this situation. Okay, so finally student, we have a simplified grammar in which we eliminate a tends to null, means this production is totally eliminated. Okay, so we look at the language G1, that is also same as the language which is given by G. Okay, you can see here it also, a language of G1 also gives the n occurrence of A, where n is greater than equals to 0. So here we have seen that elimination of a null production does not affect the language of simplified grammar, because here both are the same. But still our simplified grammar G1 having one null production s tends to null. For this s tends to null, and what happened if we eliminate this null production, we see this into our next slide. Okay, here we recall a context-free grammar G as described this, and as we generate a simplified context-free grammar G1 from the grammar G by eliminating null production A tends to null, and the simplified grammar G1 is defined like this, where we have no A tends to null production, and the simplified set of production are this. But note that the language of G1 and the language of G both are equal, because both derive the n occurrence of A, where n is greater than equals to 0. Now look, if we want to eliminate s tends to null also from a simplified grammar G1, or you can say from a grammar G. Before this, one thing should be noted here, and this is very important point of this topic. Okay, this is the important point. What it is, look at the language of G and G1 both. The language of G and G1 both contain null string in it, because when the value of n is 0, it gives us the null string. Means a null is belongs to both L of G and L of G1 both. Therefore, we cannot remove s tends to null from the grammar G or G1. If we can do this, then the resultant grammar is equivalent to grammar G2, and the language of G2 is this, in which the language of G1 does not having the null string, and like this also, and that is described by e to the power n, and the value of n is greater than 0 only, it is not equals to 0. Means next simplified grammar G2, in which we removed s tends to null also. Then the simplified grammar G2 defined by the n occurrence of A, where the value of n is greater than 0 only. This time this is not equals to 0, like L of G and L of G1, because we removed null string from that both due to elimination of s tends to null. So for the elimination of null production from a grammar G1 or G both, there are two cases. Case 1 says that if we cannot eliminate s tends to null, because if we do this, then the null string cannot be generated. Okay, and case 2 tell us if forcefully we eliminate s tends to null, then the resultant grammar does not contain null string, and that is given like this. Okay, so the next simplified grammar is G2, which is not equivalent, or we can say the LG2. Okay, this is not equivalent to L of G1, and not equivalent to L of G. So whenever a null is associated with a nullable variable, okay, and or we can say, sorry for this, whenever a null is associated with starting variable, then that language having the null string. Okay, I hope you understand. And therefore, for the elimination of s tends to null, where s is starting production, we have to take some care. Hope you understand this. So finally, student, this is very important slide where we conclude what happened, what are the situation according to the null production or a nullable variable. So far we have learned that if the null is in a grammar or a language L, then this null is associated with the starting variable. Okay, so S is a nullable variable in this case. Simply want to say your starting variable is nullable also. So there are total 3 cases. In first case, null is not, when null is not in language of G, means a language of G does not having null string. On that case, simply we remove all nullable variables, null production, and modify the available production. For this, we have theorem 4, which we discuss in our next lecture. Okay, by theorem 4, we easily eliminate nullable variables, and the resultant grammar G1 and the language of G1 is of course equals to L of G. This is also we will prove by the example. Okay, and the case second, if null is in a language of G, means null is belongs to L of G, then simplified grammar G1 can be constructed like this. Okay, in which the simplified grammar does not having the null string. Okay, this is the restriction, and we generate this as it is case 1 by using theorem 4. But we know that L of G1 not equivalent to L of G. Okay, but L of G1 is equivalent to L of G without null string. This is equivalent without null string. Okay, so finally there are the last case number 3. This is also very important. Okay, if null is in language of G, but we don't want to construct like this. Okay, means we don't want to construct an equivalent grammar L of G1 such a way that does not having null string. And simply if we want to construct a simplified grammar like that is equivalent to a given grammar L of G, okay, as it is same to same, then on that case we have to change into the simplified grammar like this. We include one more. Okay, so here we discuss how we modify or how we construct grammar G2. So for a grammar G2 that is equivalent to L of G with having the null string in a grammar or a language, that is here we define L of G of G2. Okay, so we modified set of vertices V2 of G2 like V union S2. Simple meaning is that we include one new starting variable, that is S2. Okay, this is new starting variable. Okay, and we include the new production into the set of production P2. Okay, that is what this new starting variable S2 derived the variable S, and which is the starting variable of grammar G. Okay, so this time what is happening here, because whenever null is in a grammar, and if null whenever null is in your grammar and your starting variable is associated with that null, then on anyhow your starting variable does not appear on right hand side again and again. Okay, this is happening when your grammar is recursive. Of course we discuss this with a suitable example in our next slide, but for this case you just understand, we include one new starting variable S2 into a simplified grammar G2 that derive the starting variable of G simply, and s tends to null, and s tends to null is removed and we include s tends to null. This shows that your language having the null string, but it is not now associated with the starting variable of G, which is not the starting variable in G2, because the G2 having the new starting variable, okay, as2, like this. So as2 derived null, that is for the null belongs to your language L of G, okay. So we modified like this. Of course, we discussed this with the suitable example, and we've modified our language, and we able to construct by using these modification our modified grammar. L of G2 is equivalent to L of G and having no null production of the form like this. But for the null string belongs to a language, we have a new null production, that is s tends to null in your grammar, okay, in your language. And this is only for what? For a null string which is belongs to your language, and this s2 does not appear anywhere in your right hand side of any of production. I hope you understand this. If not, just listen once again, and in next lecture we take some examples and learn very much clearly. Thank you for watching. If you have any doubt, then please mail at this. Thank you very much.